Student, I am H.G.TIWARY of DMCC Greedy. I am going to teach you function. Yesterday video I have given concept of function, kinds of functions, what is real function, onto function, that is bijective function, and domain, range, codomain. This concept I have given in previous video. In this video, I am going to teach you other kind of function which were left. So here you should see that is identity function. Identity function. What is identity function? A real function. A real function f is said to be identity function if fx is equal to x for all x belong to R. Fx is equal to x for all x belongs to R. This is the rule of identity function. Just by picture I am going to discuss you. By picture, if A, here is a B set, and here is 1, 2, 3, 4, 1, 2, 3, 4. So here 1 is related to 1 under function f, 2 is related to 2 under function f, 3 related to 3 under function f, 4 related to 4 under function f. So for identity function we see that f1 is equal to 1, f2 is equal to 2, f3 is equal to 3, and f4 is equal to 4. So what are we getting? Fx is equal to x for all x belongs to A, that is domain. This type of function is called identity function. This is the concept of identity function. Now second is signum function. Signum function, a real function fx is said to be signum function if fx is equal to mod x by x, mod x by x, x belongs to domain. Mod x by x, here is a definition of signum function. Here we also define fx is equal to mod x if x is greater than 0, x by x is equal to 1, and fx is equal to minus x by x if x is less than 0, that is equal to minus 1, and fx is equal to 0 when x is equal to 0. So it is redefined as signum function fx is equal to 1, 0, minus 1 when x is greater than 0, x is equal to 0, and x is less than 0. So this is the signum function. Here its domain is any real number, and its range will be 1, 0, minus 1. This is the range of signum function is minus 1, 0, 1. This is the range of signum function. So this type of function is called signum function, student. Now I am coming other type of function, metric function. If fx is equal to sin x, fx is equal to tan x, any trigonometric function fx is equal to, these are called trigonometric function. Fx is equal to sec x, fx is equal to cot x, these are trigonometric functions. Now, exponential function. A real function is called exponential. A real function fx is called exponential function if fx is equal to e power x. X belongs to r. These are the exponential function. Now logarithmic function a real function fx is said to be logarithmic if fx is equal to log x to the base a, gx is equal to log of x to the base e. These are the logarithmic functions. Law of logarithm. First, log m into n to the base e, log m plus log n to the base e, log m by n, log m minus log n, third, log m to the power n and log m. These are the comes under logarithm. Log of a to the base a 1, log of b to the base b 1, 5, log of 1 to the base is 0. Here there is a two base you are looking here, student watching, e and base a. E base is called Napier log, where logarithm base is e, it is called Napier log, and where base is other than e, that is called common log. This is the common log, log of 2 to the base 10. This will come under common log. And log of 2 to the base e, it is Napier log. Napier log. So these are the difference between common log and Napier log. Napier log is more authentic than common log. In physics chemistry, we use Napier log because it gives good result, students. Now next type of function I am going to discuss trigonometric function. Fx is equal to sine inverse x. Fx is equal to cos inverse x. These are the inverse trigonometric function. So these are the kinds of function which will be used in class 11. Now I am going to discuss operation on function. Operation on functions. So student, if f is a function from d1 to r and g is a function from d2 to r, here dn is the domain, r is a codomain, d2 is a domain of this function, r is a codomain, then their addition f plus g is a function from d1 intersection d2 to r. That is, if x belongs to d1 intersection d2, then f plus g x is equal to fx minus gx. Only for common elements of domain it is valid. d1 intersection d2. Similarly, f minus gx is equal to fx minus gx, where x belongs to d1 intersection d2. Only for intersection, in f into gx is equal to fx into gx for all x belong to d1 intersection d2, and f by gx is equal to fx by gx for all x belongs to d1 intersection d2, gx not equal to 0. So these are the, here also if k into fx is equal to k into f x is equal to kfx, we can write, student. So also where k is not equal to 0, k into f plus gx is equal to kfx plus kgx, x belongs to d1 intersection d2. So these are the operations of real function d1. Let it here d1 is a domain, r is a codomain, d2 is a domain, it is codomain. So their addition, subtraction, multiplication, division will be valid only for x belongs to d1 intersection d2. These are the operation on functions, student. Now we solve the problem related to this. Solve the problem related to this. Exercise 2.3, question 1. Which of the following relation or function give reason? If it is function, determine its domain and range. So student, first question of this, here we have 2, 1, 5, 1, 8, 1, given 11, 1, 14, 1, 17, 1. These are the elements of this a function. Now we have to show is it function? We have to clarify this problem is function or relation. So we will show by picture solution. Here you write A set, write element 2, 5, 8, 11, 14 and 17. Here you write B set, take the second elements, we see all the second elements are 1. So 2 is related to 1, 5 related to 1, 8 is related to 1, 11 related to 1, 14 related to 1, 70 related to 1. So all the elements of domain are related to this. So it is a function, it is a constant function. It is a function and it is a constant function because f2 is 1, f5 is 1, f8 is 1, f11 is 1, so on. So it is a constant function. It is a function because each element of domain are associated with elements of B. So it is a function. Next one, second student, second 2, 6, 3, 8, 4, 10, 5, 12, 6 and 14, 7. This is, you have to check it. Is it function or relation? We have to check this question. So for this we draw a diagram. Consider it is set A. Take 2, 4, 6, 8. First element 10, 12, 14. And it is set A. Set B. You take next element 1, 2, 3, 4, 5, 6, 7. So 2, 4, 6, 8, 10, 12, 14 I have taken, and here is in 1, 2, 3, 4, 5, 6, 7 in set B. So 2 is related to 1, 4 is related to 2, 6 is related to 3, 8 is related to 4, 10 is related to 5, 12 related to 6, 14 related to 7. So it is a function. All the elements are domain associated with element of set B, codomain. No elements are left. So it is a function. It is a function. Its domain. This is the domain. Domain of function. And this is codomain and range. Codomain and also range. Range is set B because it is one function. So it is domain of the function. It is codomain of the function. It is also range because no elements of set B are left. So it is range. Now third one I am taking. Third 5, 2, 5. So here take a picture. Set A, set B. Here you write 1, 2, 3, 5, 5. What are you observing? 1 is related to 3, 1 is related to 5, and 2 is related to 5. So here it is not a function. It is not a function, it is relation because two distinct elements of codomain related with single elements. So it is not a function. It is a relation. It is not a function because two distinct elements 3 and 5 of codomain related with single elements. So it is not a function, it is a relation. So in this way, you have to verify which one is function and which one is not a function. So this is the answer of first question, student. And range of following real function. Here first fx minus mod x, second fx root over 9 minus x. Student, domain depends upon value of x. Domain depends upon value of x and range depends upon value of y. So, for solution, fx is equal to minus mod x. So, what is the domain of this? So, domain depends upon x. If you x is 1, f1 minus 1 minus 1, x2 f2 minus 2, that is minus 2, we are saying in this way. Similarly, if x is equal to minus 5 minus 5, so it is minus 5. So what is the domain? Domain of this is any real set. Domain of fx is R. Any real number is domain of this function. Any real number is domain, and for range we see the value of y. Fx is equal to y is equal to, we are seeing minus 1, minus 2, minus 3, minus 5. Any negative values, we are getting negative value. So range, value of y is negative integers, negative real numbers. So range of fx is r minus this is the negative real number, that is set of negative real numbers. This is the domain and range of this. Now we proceed for this, find domain and range. Domain depends upon value of x and range depends upon value of y. So for second, finding domain and range, student, this is real fx, that is y is real only when 9 minus x square greater than equal to 0. If this is greater than equal to 0, then this is real. So 9 is greater than equal to x square. So x square is less than equal to 9. So x is less than equal to root over 9. X is less than equal to plus minus 3. If we take positive sign, then x is less than equal to 3. Now take negative sign, then x is greater than equal to minus 3. So domain is equal to 3 to minus 3 to 3. This is the domain of this function in a closed interval minus 3 to 3. This is the domain. For range, we take the value of y. For range, we take y root over 9 minus x square. So, squaring both sides, y square 9 minus x square. So, for y, we take x square 9 minus y square. So x root over 9 minus y square. So we will see for range here x is equal to root over 0, x is equal to root over 9 and 3, and y is 1, x is equal to root 8, and y is 3, x is equal to root 0, 0. So we see that y value is lies between 0 to 3. So range of fx is equal to 0 to 3. Minimum value is 0, maximum value is 3. Here we take 0 to 3, this is the range, and this is the domain. Domain is minus 3 to 3 and range is this. So these are the little problem of domain range. Now I am going to solve third 5. Find f0, f7, f minus 3. So put simply 0, f0, 2 into 0, minus 5, f7, 14 minus 5, 9, and f minus 3 is equal to minus 6 minus 5 minus 11. Simply we can find the value of this. Now question related to that is addition and of the function, operation on function, question related operation on function student. Function from real to real, g is a function from real to real, and fx is equal to x plus 1, gx is equal to 2x minus 3. Find f plus g, f minus g, and f by g. This is the operation related questions based upon of addition of function, subtraction of function, and multiplication. And so here we see that real to real domain of both are same. So f plus gx is equal to fx plus gx. So fx value is x plus 1, gx is 2x minus 3. So 3x minus 2. This is the value of f plus gx, student. fx plus gx. f minus gx is equal to fx minus gx, that is fx, x plus 1 minus gx, 2x minus 3. Do simplification, x plus 1 minus 2x plus 3. So minus x plus 4, student. And f by g student, f by g, f by gx, x is x plus 1, gx is 2x minus 3. In this way, we can find the value of addition of function, subtraction of function, division of function. In this way, it is related to operation on two functions. Just I discussed the theory. On that theory, they are based. Also, good questions are given in R.S. Agarwal book. So, you can choose the questions from R.S. Agarwal book and solve. Also solve NCERT questions. Thank you.